Hey, welcome back, Math Gurus. In this video, we're going to focus on compound probability. There's actually two. It's independent and then there's dependent probability. We usually just say independent probability or compound probability. We usually don't say both. Independent is definitely easier than dependent. Compound is just two or more things happening. All right, so let's get started so we can see what I'm talking about. It says, what's the probability of randomly drawing a scare-filled emoji on the first draw, replacing it, and then randomly drawing another scared-filled emoji on the second draw? Okay, so when you replace it means you take it out and you put it back in. So the chances of you getting the scare-filled emoji, both times, one event will not affect the other. Now, if you took it out and didn't put it back in, then that's a different story. So we still go back to what is probability. It's favorable, what you want, over your total outcomes. Now, when it's compound, you have to multiply both events. Now, if it's independent, your totals will not change because you take it out, but you put it back in. So let's first figure out our total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now, that means they're both going to be 16. And the reason is you take it out and you put it back in. Now, scare-filled emoji. Well, how many do we have of those? Well, this one is scare-filled. And then this one. So we have just two. We have two. We take it out, we put it back in, so we still have two. Now, you multiply straight across. No common denominator is needed. However, you can simplify first. Well, they're both even 2 over 16, so that does simplify to 1/8. And then this will also simplify to 1/8. We still times it. You multiply the numerators, you multiply denominators. 1 times 1 is 1. 8 times 8 is 64. Okay, so the chances of you drawing a scare-filled emoji twice, back to back, take out, put it back in, is 1 out of 64 chances. Okay, so let's go to the next problem. It says, what's the probability of randomly drawing an angry emoji on the first draw, replacing it? And you'll usually see replacing it or with replacement, or puts it back, anything that resembles that. And then randomly drawing a heart-filled shape on the second. Well, angry, let's look at the angry one first. There's 1, 2, 3. So I have 3 out of, let's count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 3 out of 16. So sorry about that one. And so the 16 stays the same because we know we're putting it back. And now we need the heart-filled. So for the heart-filled one would be just 1. So you would multiply top, top, bottom, bottom, numerator times numerator, denominator times denominator. And that's what I mean, 3 times 1 over 16 times 16, which is 16 squared. I should have came up with easier numbers, but I guess this is possible. And sometimes I have it all worked out before. I just didn't do it this time. 256, and my numerator is 3. Now, 3 can only be divided by 1 and 3. If by my divisibility rules, I think, I'm not sure. Let me just try it. Can they both be divided by 256 without any remainders? I'd probably not. I don't know. Nope. Just as I suspected. Okay, so this doesn't work. We're not going to worry about it. We're just going to leave it 3 out of 56. All right, so that's the last one on independent probability. Thanks for watching. I hope it helped, and don't forget to hit like and subscribe.